Well, hi, good morning. Thank you for joining me in my shop. Today is November 13th. Another gray day. The aurora, which was almost certainly visible here last night and maybe the night before too, not visible because of total cloud cover and rain. What a disappointing situation. So, yesterday I discovered this guy is really looking for 240 volts. And I've confirmed that it's really ready to run on 240 volts, and I have this transformer that is designed to take North American power and turn it into European power, which is 240 volts. That's a more European style outlet, and this is a converter to North American style plugs. So I'm going to turn this on, and then you're going to see why I'm going to want to look at this a little closer after I turn it on. So I believe we got it plugged in. Okay, I'm just going to apply some power to it. Watch what happens here. Can you hear it humming? Can you hear it humming now? The output voltage here is about 210 volts. Let's check it. So I don't like the hum. And it's probably harmless. It's probably just some of the laminations in the transformer are loose. Let's turn the transformer into a bit of a speaker. We're on volts, AC. What do you got for me here? 214. It's a little short of 240. Now I can crank up the input here. Uh-oh. Uh-oh. What happened there? Did I just lose? Maybe I just lost contact here is all that happened. Okay, that doesn't sound very good, does it? Is there something wrong with it? I don't think so. I can measure the power draw on it from this guy here. I simply switch this to there. Maybe that's not the way to do it. So the thing about a big transformer like this, a big coil sitting here, is the current and voltage are going to go out of phase through this thing, and this can throw off all kinds of instruments that are trying to measure wattage and things like that. So for instance, if we try this guy, how many watts is this thing using right now? So this is reporting 12 watts of power. 12 watts of power just sitting here like this. If we crank it up again to try to get the output from it, 23 watts, 28 watts, 30 watts. Seems like a little bit more than you would want. But again, the measuring technique here to measure watts is probably dependent on the phase and current being, the phase and voltage being in phase. The voltage and current being in phase. I gotta get my words in phase. So I've never actually used this for any purpose. It has only 2 wires going into it. There's probably there's no ground available here. So even if it was a 3-pronged plug, it still would not receive a grounding. Maybe we should just open this guy up and look inside before I start just using it and not paying attention to it. That's the first plan. Investigate the power transformer here and see what's going on with it. Nice box. I mean, look, it's a beautiful box. Lovely little handle, drilled with ventilation holes all through it. It's pretty nice. Okay, let's do that next. Okay, I've got almost all the screws out of it. Last screw. At least for the top here. Lovely screws. Get an X penciled into here. This is probably marking the front or something like that when he was making it. Whoever made the box. Look inside now. There's the matching X there. Okay, so I gotta pull the plug out here just to be safe. So it's kind of a clunky old transformer, isn't it? And it's got quite a number of connections here. So we got power coming in here. And we've got the output going there. And then we've got different windings, I guess, connected back here. It all seems pretty solid enough. What's happening behind me? A cat confrontation is going on. Okay, any other secrets in there? I don't see any secrets. What's going on, Shadow? What's the problem? Her problem is there's 2 other cats in the house. That's her problem. Okay. Okay, I'll leave the top off. I can feel the heat of the transformer that way. There's no heat in it. We'll assume it's noisy because it's a noisy transformer. I don't see there's anything I can do about it. Sometimes there's bolts holding the transformer together, holding the laminations together, and those bolts can come loose. I don't think that's at all the case here. Okay, I should relocate this so it's not so easily heard. How long is this cord? So once I get this set up, we will talk some more about this guy, as I read up on him last night. It's very interesting. Interesting parts. Yeah, that cord will easily get to the ground. Okay, I'll rearrange stuff here. Okay, if you're hearing a bit of a roar, that's my furnace fan operating. So here's the plan. I've got the big transformer on the floor underneath my bench where we probably won't be able to hear much of it. I've got the radio plugged into the transformer. Got the transformer plugged into a power bar, which is this plug goes to. Plug it in there, and bingo, voltage will show up here. First, I'll have the set turned off. Take my voltmeter here and check for voltage, see what it is before turning the set on. The transformers seem to be struggling anything above 210 or so. So we're probably going to run it at 210 or somewhere around there, and we'll see. We'll see what happens. Pushing it higher, the transformer gets more and more noisy. It's probably really not a problem, but just sounds terrible and scares me. That's what I can say about it. I have a story about a humming transformer. Do you want to hear a story about a humming transformer? Yeah, why don't I do this? I'll tell you this quick story, okay? It's going to take a couple minutes to tell the story. Back when I was working at the power company, Toronto Hydro, my job was to chase what are called stray currents from the transit system on the hydro system. Do you want me to say that again? My job was to trace and chase and control stray DC current leaking from the transit system, streetcars and subways, onto things like water mains and power cable neutral systems underground. That was my job. So yes, some of the DC power that makes a streetcar go down the street causes effects in the soil, which can cause current to flow on structures like gas pipes, water pipes, and other things. And the unfortunate result of that is you can have very aggressive corrosion occur. Very focused and very aggressive corrosion. Put a hole in a water main pretty quick and things like that. So that this DC current is flowing in the neutral system, the grounding systems. You can go into a house in Toronto, especially if you're anywhere near downtown where the streetcar, the subway runs. Go down in the basement with a clamp-on DC ammeter, clamp onto the ground wire that runs between the water service pipe and the power system neutral in your house. Clamp on that and take a look. And what you'll see is a small current fluctuating, like just going up and down, probably going in one direction and then fluctuating from there. I'm sort of drawing a chart here. When the streetcars are really going, the current is higher, the fluctuations are greater, and at night, when everything calms down, the streetcars stop running, the subway shuts down at 2 o'clock, the whole thing comes down to a steady state, sits there, and then 6 o'clock in the morning, or whenever they start running, you get that current flow again on the ground wire between your water service pipe and your hydro neutral. This current is flowing everywhere. The stray DC current's flowing everywhere. So now here's the story. I get a phone call from guys in another power company next to Toronto, in a city that no longer exists called North York. These cities got amalgamated, but there was once 6 cities where Toronto is, where one city is now. Anyway, North York guy calls me up and goes, so I understand you deal with this stray current problem. We seem to have, we don't normally worry about this. There's no streetcar and whatnot up in their area, subway up there. But we've got something going on here. We don't know what's going on. We've got a transformer with no load on it that's overheating. Now we're talking about a big transformer. We're not talking about one like the one under my bench. We're talking about a 500 kVA transformer, size of an SUV type thing. And it's humming wildly. Can you come up and just check it out? Well, okay. Why not? It sounds like fun. So jump in my truck, drive up there. We get to the location where this problem is. And there's a building just been built, maybe 10 stories high. It's not occupied. The ground isn't even finished yet. It's all raw dirt and stuff. And there's the transformer vault with the transformer in it. It's getting a primary supply, and then the secondaries are feeding the building. Except there's nothing going on in the building, and I think the secondary supplies weren't even fused yet, so there's no connection. There's no load on this transformer. So we're walking towards the transformer vault. The transformer vault is a room the size of a very large living room, let's put it that way. We're walking towards it, and as I'm getting close to it, I can start to hear, what the heck is that? That's the transformer down in the vault under the ground humming. Now, I'm not doing a very good imitation of it. We get there, and the first thing I think is, I don't want to go in this vault. This transformer is screaming. I mean, it's just humming like a son of a gun. But down we go. We get in the vault, we can't talk. It's too loud. And the hum is going, oh my God, there's no load on the transformer, and it's hot. They say, what's going on? I said, well, you've got stray current in this transformer somehow. I don't know how, but somehow you do. Okay, more technical explanation. Transformers can be fed on the primary side in power systems in 2 ways. One is a delta feed, and the other one is a Y feed. With a Y feed, there's a ground or a neutral line. With a delta feed, there isn't. There's just the three phase power feeds coming in. But with Y, you've got a ground wire, and they had wired this thing up Y on the primary side, which is something you don't normally do or don't commonly do in these systems. But anyway, they had. and I was able to throw a clamp-on ammeter I brought with me onto a neutral wire in their transformer vault, and I showed them the current flow going up and down, and it matched the sound in the transformer. Then we got the heck out because I was scared out of my wits being in there. We got out, and I explained to them what I think is going on, and that they had to do something to maybe change the transformer to a different transformer with a delta feed, so there's no possibility of this leaking stray ground current from getting into the transformer. Didn't hear much more about it ever again, except that the transformer manufacturer had been, of course, informed of this problem, because the first thing that the company said was, yeah, your transformer is defective. And he did some studies in his factory and determined that as little as 50 milliamps of DC current could throw a big transformer like that into saturation, and then it starts making all that loud humming, and it starts getting hot too. 50 milliamps. So the stray current I typically measured was an amp or two, stuff like that, where I chased it, not milliamps. Anyway, there's a story for you. So humming transformer makes me nervous. So okay, I hope you enjoyed that story. If you are in the city of Toronto and you are an electrical person and you do have a clamp-on DC ammeter, I invite you to go and see if I'm telling the truth. If you're anywhere near the subway or streetcar system, go down, clamp on your ground wire, and see what's happening. Gee, I should try it here. I'm 100 miles from any DC transit system. What I said is basically true in any city with a streetcar system or a DC powered subway system. The same thing is happening. Okay, let's try this. I think I'm ready. So we'll practice with the voltmeter. There's 3 wires coming out of this cable, out of the power plug. One is green, and I've seen it's right to the chassis. And then there's 2 more wires. There's a brown wire and a blue wire, and they go up to the on-off switch here. The switch is off, so it will not come on. The voltage will appear. I can measure it and see what it is, see what we're getting. If we're anywhere near 240, we'll also find out how hummy this transformer is down below. Do we still hear it? Okay. Through the dim bulbs for some reason. Here we go. Well, I don't hear any. I mean, this dim bulb is on just from the inductive load. Can I call it that? I guess so. Inductive load of the transformer. But I barely hear it. Let's see what we're getting up here for. Wow, we can see right here. You can see right here. 87 volts. Wow, this is the way to do it, Jim. Don't down. This is a much better thing to do. This is the FM antenna here that's flopping around. Come on, stay up where I can see it. Too many times around. Somebody's got to cooperate here. I want to go all the way that way. How about that? No, you still don't want to go. Come on, man. Messing around with this. Hey, there we go. That's good. That's staring me right in the face now. 87's a little low. 87. No, this is the supply voltage, Jim. You bozo. That's not the that's not the output of the transformer. Okay, we're back to looking over here. Let's put the meter on. That's okay. I'll figure everything out, just in time. Let's take a look at chassis to the 2 colored wires here. Okay, chassis. This is the blue wire. 56. And this is the brown wire. 79. And then this is in between. This is between the blue and the brown. So this should really be the this should be it. 158. Okay, so I'm going to cut the power. I'm going to put a couple clip leads in here and clip the meter on because I'm very uncomfortable poking those leads down there. knot in these to indicate they're bad. Usually I put them off to the side then too, but nothing wrong with that. Okay, once again, power's off. So, I mean, the object here is to be aware of what the supply voltage is in reality. We don't have to get all the way to 240, I'm sure. This might well work at 200. Oh boy, that's way down there. The question would be, would it, you know, if it works at 200, is it doing what it would do at 240, pretty much, and so I can carry on at 200? How would I even know? You'd have to run it at 200 and then run it at 240 and compare it, I guess. Why would I run it at just 240? What am I worried about? It's too hard on the transformer down there, so it appears. Shouldn't be, though. Okay, so now we're hooked up so we can read the voltage. Ooh. Been the end of my meter right there. So we can read the supply voltage. Okay, I'll turn it on again, but the set is not on. And when it does come on, it'll be feeding the sound right into my sound system. So we're going to hear what's up. And it is connected still to a basic dipole FM antenna, but in a terrible place here in my shop. Okay, through the dim bulbs. Oh, you know, the dim bulbs. So the current flow through these bulbs is causing them to glow. But probably the current and the voltage in the transformer are out of phase, way out of phase, probably. This is still dropping the supply voltage though. So that's why we only have 87 here. If I flip this up, I got 159. Let me flip this up. Okay, so we got 100 on the supply side. You can see this is on wattage here. We need this on output. So you probably can't see it. 120 is there. This is just below 110 on there. Here it shows 100. Somewhere 10 volts being lost in my wires here. I don't know. It's kind of weird. Maybe this meter's not accurate. 181 on the machine. That's way low. They really want it, 200 anyway. The transformer's humming, but you gotta stick your head down there to hear it. I've got this switched up here, which means it's the dim bulbs are out of the circuit. Well, how high can we get this? There we go. Now I'm sure you can hear the transformer humming now. $215. Okay, what if I just shove it all the way? Ooh, what's that sound? So I think that's the laminations really vibrating down there. We're just below that. Not that the sound means anything, it's just disturbing to me. We're at 220. That sounds pretty good. That sounds like something we can run it with. Of course, when I turn the set on, this 220 is going to drop. I think we're ready to go, but we're not going to go. I'm going to go, drink some coffee, and then we're going to turn this guy on and see what we can tune in. Okay, we're about ready to start now. With the microphones live in here, you can hear my furnace running and other sounds and whatnot. I think what I'll do when we start this guy up, I'll turn the microphones off, and all that you'll hear is whatever's coming out of here, if anything at all. Now, the word is this works. It's here for a checkup, tune-up. It's not here because it doesn't work. So hopefully we're going to hear something here. Let's get it tuned somewhere. So the local station that it was at 95.7, it would be somewhere right in this area here. couple warnings about this radio. One of you emailed me, and I also studied the schematic and discovered that yes, there is B plus on the back of these switches here. Just something to be aware of. You wouldn't normally expect that, or you might not think of it and get a shock off it. Okay, we're ready to go. I can't delay any longer, so we'll apply power. It's still off. Okay, and oh shoot, power off for a sec here. Okay, turn power back on. Isn't this supposed to show something here? What has happened? Am I crazy? This says 13 volts. It should say like 200. What's different here? Because I have the dim bulbs in. No, we're at 97 volts supply. You can't even see this thing, can you? There, 14 volts. What happened? Transformer's humming. What? What has happened here? What have I done? Have I done something stupid? That's usually the case. Is this clip lead not really touching here? Oh, what happened here? This came off. Okay, power down. How did that come off? Don't know how that could have come off. Here we go again. There we are. Okay. 175. Let's go a little higher. Can we go a little higher, please? Like I say, as soon as I turn the power on, it's going to go down. That's the top. Oh, I got the dim bulbs in. That's why. Okay, back down. Dim bulbs out. Back up. Yeah, this time we're going to go up around 2. You can hear the transformer humming away. Let's try 220. 220 sounds nice to me. Okay, please don't blow up on me when I do this. This might drop a lot though. There we go. And yeah, microphone's still up, audio up on the amp. Okay, we don't hear a thing. That's good. I put the volume all the way up. We didn't hear anything. Here we go. Okay, nice bright light. Tube's warming up. Voltage steady. Volume up. Volume up. Who's humming? Okay, down on the microphone. We were doing great there. Up on the, everything was good, and then I went and turned this, and it all went quiet. Why would that be? Why would it go quiet? Just because the plug over here is not right. Watch your ears now. No, that's not it. What happened here? It worked, and then it stuck. Why would you do that? Why? What? How could this happen? Not a particularly good sign. Okay, once again. Well, that's the microphones. The hiss you're hearing is the microphones. This is the radio. Where? What? How come? 216. How come? Sensitivity's on local. This switch seems to engage another whole stage of amplification. When I looked at the schematic, so that this is really not just this is a big deal. Turning. So this is local, which means it's not using a stage, I believe, from my assessment. How's this happen? How do we end up with it working and then not? I'm worried it's going to come on and blow our ears off. I'm wearing headphones. You could be too. Nothing. Well, that was short-lived. Could it be a tube contact? Something stupid like that. What did I do? It came on, I jumped at the volume control. So what? How could that kibosh things? Well, okay. Right. I'm paralyzed. I really don't know what could have happened here. The tube thing. Okay, let me just try not to have this volume too high when we discover something here. I'll use my finger. So these tubes are all held in with clips, so not so likely that would do anything. Nothing whatsoever, not a sound. We're not getting a sound. We're not getting any sound at all. But we did for a brief moment there. The magic eye appears to be, well, it's glowing. So how have we gone? Is it a tuning thing? Can't imagine that would have any effect on anything. At any moment, this thing can come to life and blow our ears off, so be aware. Well, so yeah, the hum you're hearing is the transformer down below. So, well, let's turn it off. We'll turn it back on and see if it doesn't work again for a moment. Okay, hands on the volume controls, everybody. Here we go again. Doesn't make no difference on the volume control.
Have burdens on my shoulders all my life.
Look right. I need a pointer here. Something here. Okay, look right here. You see this metal piece? I'm tapping it. It's rubbing against the flywheel and giving this. Kind of crazy.
Was coming from, but I really felt that before. Or you feel like you're
Good. We got some talk
put
here.
into a box or pigeonholed or anything, and you want to be able to explore and be creative and take a sharp, left turn and do something interesting. And I've been able to.
I'm going to cut off the microphone so we hear just
easily.
this.
I mean, I get it. I mean, there's a scene in the. I appreciate you saying that because there's a scene where Gustav is the auteur.
Yes, played by Stellan Skarsgård.
Amazing. one point pretty negatively about actors, like they have no real agency or power. And when I hear you say that, like, hey, I know what it's like to have like a career imposed on me, I also know that like you and your sister started to produce something. Is that a reaction to that? Is that a reaction to feeling like maybe you can take control over the stories that are going to tell or stories that are told?
Yeah, I think that it's like a natural growth. I've now really been able to form shows and documentaries, and it's been very exciting, and possibly as a reaction to that.
Well, I mean, it's sort of my job to read too much into that kind of stuff.
Totally.
I think what I'm seeing is
a lot of people are now. You know, they're producing their. I think that it's an amazing way to kind of find the projects that you want to do instead of them being kind of a
I guess I feel like an intentionality.
Cause the spirit was moving over the water.
Oh my god, I've been talking away like crazy without the microphones on. That's okay. That's okay. So you were probably just observing the same things. One of the things I've noticed is the hum, and it's a modulation hum. It appears when you tune in a signal. Let's tune in something. That's too weak. Where'd he go? Very, very strong signal. The hum seems to disappear. Now that could be maybe because of the limiter stage. No, this thing seems to get quieter. No, it just still doesn't do anything. Get fooling around here. So this sound here, I don't know what that is. Let's see. Let's put a little more volume on it. It's pretty good once you get it tuned in. So I'm going to check now for the effect. I'm going to check now for the effect of the limiter. So I'm going to tune in a station and sort of tune it in so it gets stronger and stronger, and listen to the noise and see if the noise doesn't cut right out the background noise in that. And that's to judge whether the signal is getting strong enough to operate the limiter or to work properly with the limiter. I don't know. Let's see.
Visit capvaxa.ca. Capvaxa helps protect against IPD. It may not protect everyone who gets vaccinated. Side effects and allergic reactions can occur.
Between now and November 15th, experience unstoppable comfort and unbelievable deals with Mariposa Building Services, Aurelia's trusted HVAC contractor. Right now, buy a Train furnace and air conditioner or heat pump package and get instant savings up to $1,800. Plus, take advantage of government rebates worth up to $7,500 on central and ductless heat pumps. Don't wait. These offers end November 15th. Unstoppable comfort, unbelievable deals.
November
Only
15th.
Train, installed by Mariposa Building.
Better hurry. So you hear all that noise? The signal is not being limited in the limiter, and the noise is coming through. The stronger signal reaches the limits. Like the weak signal, just the limits. Like that. The strong signal gets beyond it. The limiter trims off all the amplitude modulation. It limits the amplitude. Blow my ears off, please don't do that. See, like this signal, the noise doesn't go away. The signal is not strong enough to hit the limits, basically.
You told me twice, you say it again 1,000 times. So with the love.
Oh,
Like,
good.
kind of, and I'll. So, net sentimental value. It's in some ways about the cost of recognition and the cost of fame. To me, that's what I was watching. You know, like I was watching someone who, this director sort of give up on his family and like the quest for art and the quest for fame and the consequences of that he has found in his own personal life.
Okay, so you can hear now the hum that's in here without this going, with the microphones out. And that's this power supply watch. And now there's still another hum in here. Who knows? That's me. I'm humming. Okay, so my assessment is, yeah, this thing does work pretty good. Not sure about the accuracy of the dial here. It looked like it's off quite a ways. I was picking up what I think is 95.7. I was picking it up over here. So it dials out a bit, where the alignment is out a bit. The hum. So of course we need to suspect the power supply is humming. There's the power supply filter, and it's this top rubber part here is a big bulge in it right here. It's not a good sign. And that's a 40-40-40 capacitor. I think it's a 3-part capacitor. Probably that's the source of the hum. We replace this or supplement it. I won't replace it. I'll take it out of the circuit and put other capacitors underneath. So it still looks like this on the top, but underneath it will be a little different. That will probably eliminate the hum. And that's probably the first thing that we should really do before anything else. Good news is, I mean, the thing works, so the tubes are good. That's really great. And you know, probably an alignment would be very, very useful. As for replacing components, I believe there's some information about tube socket resistances and other stuff. We can poke around with that information, see if we can locate something that needs to be replaced. Let's look at the capacitors again, because what I'm doing here is I'm planning my approach. I'll take this off here. We better unplug this to be absolutely sure. And we want to look underneath it. So tip it up. Let's tip it up this way. So looking again at this. So what I'm not seeing are a whole bunch of wax capacitors. That's a good thing to start with. A couple electrolytics. This one's probably electrolytic here. This one here. They should probably go. And just on the face of it. And I think there's might be a molded one right here. Maybe it should go too. After that, kind of a random replacement of capacitors may not be a smart move. But we're doing the ohm tests and other things, we might pick up on something that really is in trouble. But I don't think that's the case. I think really what's happening here is alignment, I'm going to guess. a little bit of alignment would pick this guy up, and the hum goes with the power supply filter capacitors, and that's probably where this is going. Where are we at today? 10:30. It's still early. Let's look more closely at the job of replacing this capacitor. So first of all, lots of open space in here. The pins are right out exposed. Easy to get to. Did a really nice wiring job in here. I mean, look, he's tried to, as much as possible, run the wires at right angles all through here. Nice, neat job. The guy who designed and built this. Oh, that's right. What's this? Hold on a moment. What's going on with this? This is cut. Where's the other part? Where's the other end of it? Where can it go? Okay, I can barely get here. Where's it? This is cut. This is the local distance switch. Let's cut this away. You know, when I looked at the schematic, I couldn't figure out how, when you have it set to local, the signal gets, and when you do that, what you're doing is you're cutting the B plus off from this amplifier at the very front. We could spend some time looking at the schematic. Why don't we do that? Yeah, let's do that. We'll study the schematic for a little bit. Okay, let's take a look at the manual here. So Trough-Line. Why is it called a Trough-Line? I didn't point this out so far today, but yesterday I pointed to this big metal tube that's inside this receiver, and I scratched my head and wondered, what the heck is that doing in there? Turns out that's a very interesting component inside this tuner. It's a technique for getting an inductance that's extremely stable. It's based on transmission line theory, and it's basically a replacement for a coil, where a coil won't provide a stable inductance as it heats up and cools down, whereas this rather large technique that he used inside this receiver is very stable even if you heat it up or cool it down a bit. It's called a Trough-Line because originally it wasn't a tube, it was a trough, and that's why it's called Trough-Line. Maybe he could have called this model, the Mark II, the tube line, but he didn't. Okay, Trough-Line. So there's no trough, but there's a tube. And that's what it is. So back at the time these things were being made, most FM receivers had difficulties with frequency stability. And you'd turn them on and you'd have to retune them a couple of times until they got fully warmed up, which might take quite a while. It might take half an hour. So it was constantly drifting off station because the local oscillator was drifting because the inductor was drifting. So he came out with this to combat that problem, and there's other features inside this thing too, which I think are advanced. Or this guy was no slouch as an engineer, that's for sure. So what we got in the manual here, we've got excellent diagrams showing us the part locations and all that stuff. That should become interesting. We've got a 2-page schematic here. We've got a list of parts. These are the tubes here, and I think these are also the alignment adjustments pointed out, L8 and stuff like that. This is more parts list. Where's the alignment instructions? What happened to them? Did I go right by them? Controls. Fixed tubes. Where's the alignment instructions? I need the, oh, here they are. No, this is resistance readings. Well, there appears to be no alignment. Maybe they're up here? No, there's no alignment instructions. Oh my. What are we going to do now? That's, maybe it's in the fine print here. I don't think so. This is not something you align casually. There needs to be an instruction page on it. Oh, I didn't notice this before. I studied this last night for a while. I did not notice it. I didn't look for it. Okay, let's look at the schematic for a moment. We should look at the power supply of the radio. Here it is here. Let's zoom in a bit. Here. Very straightforward power supply. We should look out here too. So see this on-off switch operates 2 switches. They're just in series. Well, one of them is dirty. Anyway, that's so we can probably fix that up. This is giving. It's interesting. This is 125 volts here, 117 volts. So this is not the. Ooh, maybe I better not pay too close attention to this. Could be the only difference in like this 120 volt version is a different transformer. It might all be the same beyond it. Yikes. Okay, so we're going through the power supply, a couple hundred volts, 40 capacitor. I'm not sure what these are here. What this is, something unusual here. 1000 picofarad. I'm not sure what he's got going here. 1000 ohm 5 watt resistor. We should take a look at that. And the output's supposed to be 155. Another 40 here. So that's the power supply. Probably these two guys are causing the hum. Would have been nice if he put an inductor in here, but he didn't. He put a resistor. If we look up here, we see the, let's see, the output of the power supply is a dot. The output is a dot, but that's funny because up here the input is an arrow. 155, 155. We should have a dot there, shouldn't they? Or have an arrow down here? So here's the various places where the power supply feeds in. So this is the AFC circuit. The supply is all the time onto it. The switch here is switching, looks like it's just grounding the input to this. So some of these circuits, they managed to make the tube appear like a varying inductance to a tuned circuit. I don't really know what they're doing here, but that's the kind of thing that could be done with tubes and a lot more knowledge than I have. And so you can get the AFC effect by pushing the local oscillator frequency up or down a little bit based on feedback coming along, something of that sort. Feedback from the output. There's something more to recognize about this switch though, because here this is pretty passive, but at the same time the AFC switch is doing something else, and I found it down here, and thank you to the person who warned me about this. The switch has another duty, and that is turning on and off the tuning indicator, the magic eye. And in that case you're switching 155 volts. So on the back of the switch is the high voltage. I think I mentioned that earlier. That's just, thank you again for sending me the warning. Now the other switch that's in this radio, this one here, this is the one that has the wires cut from it, right? Let me just make sure yeah, this is the one with the wires cut from it, which would explain why it doesn't do anything. And so in this case you have a 155 volt supply and a switching it on and off. So it's switched on, you've got B plus up to this unusual arrangement here of a 2-part tube, and he's put these in series. So if you follow the B plus through the tube to the plate of the other one. So that's really quite odd. He's got 150 volts at the plate on this one, and he's got 75 volts on the plate of this one. 75 is half of 150. And there's really, between the plate and the cathode here, only 75 volts. He split it on these two tubes and put them, kind of stack them on top of each other. So I've never seen anything like that before. Exactly what the benefit is of doing it this way. Like, why not put 75 volts on both? And I don't know, there must be something. some kind of advantage to doing this. So, you know, clever engineer. You gotta be pretty clever to take on something like this, to even think you can pull it off. I mean, to design and build something like this. It'd be interesting to know how big the company was that was doing these. So why am I looking at it? Because I'm looking at the switch here. So with this cut away, there's no way for B plus to get up into this circuit. So that's a normal condition when you have this thing switched to local. Local cuts the B plus off. So the question would be, the signal out here, how is it getting over here now? I couldn't figure that out. I looked at this at length, and I couldn't see any way, once you turn this guy off, for the antenna signal to get over here. So I don't know what's going on. Now, either the person who's cut the switch away has either made this permanent, so it's always on and operating. That's my guess. So that's what he's done. And he's just done away with the switch. It's probably a dumb idea anyway, or I don't know. Is it possible that you're cutting off the antenna too and just trying to pick stuff up here? I can't imagine that. So just looking along the schematic quickly, it's got these filters here, which are a little unusual. Another one here. And then we're getting into the IF over here, the local oscillators down here that do not adjust. Can't remember what MPO stands for again, I've forgotten. So that's enough of a look. What am I going to do about the no alignment instructions? They must be on another document somewhere. Manufacturer recommends alignment not be attempted unless this equipment is available. Unless what equipment? What equipment? Unless specialized equipment is available. Well, I do have specialized equipment here, actually. FM equipment. Oh my gosh. There really is no alignment instructions. I figured I just haven't kind of clued into them, but they really aren't. There aren't any. Okay. That's the story on the schematic. Okay, so we'll put a couple of these guys in here. These are 400 volt, 47 microfarad capacitors. Which, don't you come off easy? No. Oh. Now there's 3 leads here. How many was it? See how this is soldered down right here? So that's an indication, and it's a metal shell capacitor, that the metal shell is the negative, and these 3 are all capacitors. None of these are negative or neutral. But it has a word here. It says, I would say con is what it says. What would that be? Common? That's common with an M. The wire immediately comes to this terminal. Now, what's going on here? Is this a pass-through, or is this a terminal to the chassis? I don't know yet. We'll find out. In the schematic we looked at in the power supply, there were only 2 capacitors. It's this one and this one with this resistor in between, which we need also to check. But we do need to sort out what this is. Now this is, the red one here is insulated. Pretty sure this is another capacitor. I'm pretty sure this is a pass-through here, not a terminal. And there's a lot of cases where the connection to the chassis has been made through screw connections, screw terminal. So I think these are all pass-throughs. Besides, why would they bring it over here? They could have brought it there if this was a negative. It can't be a negative. And where does it go? It disappears. It's a purple wire. Appears to go to this tube pin right here. Who knows what that is offhand. Okay, let's look at the can. Because although there's two capacitors in the power supply, there's potentially another capacitor for bypass purposes in here. 40, 40, 40. So it says 40 millifarads red, 40 millifarads yellow, 40 millifarads green. Okay, well that's pretty straightforward. They're all, what's the voltage here? 300 volt. So I'm putting in 400 volt. That should do it. Okay, and what we're going to do also is we're going to trim the terminals off the capacitor once we're done here. So I actually need 3 of these guys. If this one is a bypass capacitor, it doesn't need to be a 400 volt one. Let's take a look at the schematic and just see what that might reveal here. What does it reveal? So we're down to power supply, 40 and a 40, only 240. So where's the last 40? The last 40, I saw it up. Well, if it's part of the output tube, it would be up in this area here. There's a 0.1 there. Did anybody spot another 40? I know I saw it. I thought I saw it on the first page, actually. Up around in here. There it is, 40. Green dot. They tell you which one it is too. Green dot, eh? So if I look here, green dot. Well, that's right on the this one is wait a minute. Green dot. So the green dot has the resistor connected to it. Well, what does it show on the power supply then? Here it is right here. I can get the whole thing on here. Yellow dot and red dot. So we would expect to find between the red dot and the yellow dot a 1000 ohm resistor. And what I see, there's no resistor. The resistor is between the yellow and the green. Something funny going on here. I'm looking at the American one, aren't I? I'm looking at this. 117. Better not follow this too closely. Better find another schematic. Is there going to be another schematic? I thought I picked this one because it was the export one. Importer. Washington, New York. So this one was imported into the States, this schematic. But my radio was imported probably into Canada, and it may be different. Or, you know what? It was brought over. It wasn't imported. It was brought over. That's why it's 240. So we need to find a British version of this, not the American version. You see the knobs are different here, too. The front is actually a little bit different. This is not the same one. Okay, that's now. Can I continue with what I'm doing here? I really better not. I really better find the right schematic here. Okay, so here's another schematic I've downloaded. Don't like this one too much. Kind of stretched in the vertical. Just says circuit diagram. But I have looked at it long enough to realize, yeah, this is the same radio I've got, receiver I've got. So if we look at the power supply here, it's right in here. And we see, again, two 40 microfarad capacitors. And there's a 1000 ohm resistor here. Now when I look in the radio, we'll look at this together. This looks more like a 3000 or something like that. Just based on the color coding of the resistor. So, but it's definitely between the two capacitors. It's right mounted right on the capacitor. So no question about that. Notice the voltage there is 210 volts. Now the other large one is here. The third one is over here. So I wonder what voltage is it sustaining, and up here it says 105 volts. Right off of this line here. 24 volts. Okay, don't even know exactly what's going on here. I'm not going to bother tracing it all, but in any case, the voltage sustained by this part of the capacitor is only 100 volts. So I'm going to put a smaller rated capacitor here. So I'll put the two 400s here, and I'll put a 160 here. All of them 47s instead of 40s, which not a big deal. And we'll see what kind of hum result we get with that. Okay. Yeah, let's check out this resistor. There's the resistor right there. And the schematic says it's 1,000. So, you know, that's brown, black, red. This one looks like orange, brown, red. 3,000. Okay, so I think that should do it there. $3,000, $3,500. That's way and a far different than what's in the schematic. I mean, that's way different. Has this been replaced? I don't think so. Offhand, sure looks like original work in here. This thing here, is it a ground connection? Ooh, what was that? That was a capacitor charging, I think. No, that's not. That is not. Okay, so these are pass-throughs. These things are shown on the schematic. They are shown as a, it looks like a capacitor wrapped around the wire lead. Yeah, there's a little tiny resistor here. There's another one over here. Okay, just looking to see if I can identify that work has been done. Like there's another resistor here. It looks a little newish. There's a number of them in here. Like this one here I saw before looked a little newish. Yeah, this one's soldered in the float here. It's just floating. I don't know. I can't be sure. There's all kinds of different resistors in here. Different like styles or manufacturers or whatever. Not a lot of consistency. Okay, so the assumption then is it's not even an assumption. This is the one that's heading to a different part of the circuit, and these are where the 240s would go, and then the grounding would try to ground it onto here. That might be a little tough. I could lift the screw and screw it down. Yeah, it's not the best way to do it. There's really not a there's a grounded terminal here. It has one component on it. Grounded terminal way over here, and that would appear to be connected right here also. So this is the antenna connection. Yeah, and it actually shows a chassis connection right here. So that's why I could even use that. Let's see what this looks like if I spread these out, place them in here. First of all, do they really fit? If I get it right down flat. Oh yeah. If I can get it right down flat, they fit fine. They fit fine. We would do something like that. And then the other one, we would do something like that. Or would we rather come over here? What about over this way? We could do one over this way and one over this way. That's two different this ways. this way and that way. That's not bad. I mean, lay this one can lay in here. And this guy can find a comfortable spot over here somewhere. Something maybe like this. Yeah, he'd be happy there. And then the little brother, we could nip this wire and attach to this terminal, and then I got to pick up a ground from here. Maybe up to here again? Let's see if we can make it. I can actually make that. So this guy would go in, and he would find, oops, this way. No, this way. He would find a nice place to rest. They could even attach the negative to the negative of this one. And it's sort of get a shorter journey over there. That's the plan. I got a plan. Gonna do it now. Okay, almost ready for another test. So I've installed the replacement capacitors here. We'll do the negative check. The negative. Negative and negative. Thumbs up on that. Good. What I need to do is cut these terminals. Wait a minute, I did not solder this one. Hey, not so good. Not so good. How did I miss that? I have my ways. So as for the resistor here, although the schematic says 3000, this has clearly been put in the factory, so they may have made a change at some point and decided 3000 was better than 1000. I don't know, but I'm not going to change it based on nothing really so far. Yeah, so we're going to cut those off now. So I need my heavier cutters here. Some of these come off easy and some do not. Just make sure we get underneath all the wires. Let's go this way first. Oh, that's easy. Easily cut. Occasionally these are so hard to cut, you end up, you know, putting so much power into it, you end up doing something bad somewhere. I don't want that to happen. Okay, this one off. Okay, now just because they're off doesn't mean they're not in contact. Just like I gotta put a little piece of cardboard in there or something. Maybe just do something temporarily here. Now I've done this without really proving that the capacitor was humming. You know, I didn't really take a test directly on it. But Bata. Okay, let's get the guy here. Another run for his money here. Okay, so just to clear my head here, antenna switch is off right now. We did fiddle in the power supply, so we definitely want to use the dim bulbs first. And just doesn't want to show me his face here, this guy. There we are. Okay, get the solder out of here. Anything else I need to do before trying this? Right, headphones, audio. Okay. Just having a quiet moment of reflection before doing this. Okay, here we go. Power on through the bulbs. So the bulbs have come on really bright because I got the voltage cranked up, and that's nothing more than the inductive load of the transformer. So now we'll turn this on. Watch what the lights do here. They actually got duller. Isn't that kind of weird? You increase the load, the lights got duller. Think about that for a while. So we're 90 volts into the transformer, and I don't have the output voltage monitored now. Volume up over here. Oh, there we are.
To retailers, persuading them to stock bazooka gum. The company's
exactly the same hump still there.
Figuring out a way to encourage brand loyalty. It began offering prizes to kids that could be redeemed with comics. For example, you could get a necklace by sending in 100 bazooka comics, or a pocket knife for 375 comics. Before long, kids were buying 500,000 pieces of bazooka gum every year. Tops created 1,500 Bazooka Joe comics over the decades and came to realize they could recycle them every 7 years.
Just reorienting the antenna.
The main target for Bazooka was kids 6 to 13.
This is a great show, by the way, when
and
we're
every
listening
7
to it.
years, a new generation arrived who were fresh to the comics. Every so often, Bazooka Joe was updated to keep pace with the times. His look changed first in the early 60s, then again in the 80s.
I had the tone control set so the treble was cut back, but now they're neutralized, so you're listening to the neutralized tone from here.
Remained. Then, in 2012, Tops faced a crisis. Sales dropped
Listen to the
48%. So, after 59 years, the company decided to discontinue the
get rid of the
famous
microphones
Bazooka
here.
Joe comics. The Bazooka packaging was completely redesigned, a new flavor was added, and brain teasers replaced the comics. The next few years saw a resurgence in all things retro. Tops responded to the trend by finally answering the #1 request they kept hearing from customers: bring back the comics. So, in 2019, Tops announced a limited edition throwback pack. It featured the nostalgic packaging and original flavor Bazooka bubblegum wrapped in classic Bazooka Joe comics. Last year, Bazooka bubblegum
We're listening to
celebrated its
91.5.
75th anniversary.
Look on the dial here.
After all this time, the bubble still hasn't burst.
Okay, I gotta remember to turn the microphones up before I start talking. So, when you tune through an FM station, you usually find it three times. They're really clear, strong signals in the middle. But as you approach it, you may tune in a little bit, then you get it, then you tune in a little bit on the way out. If these things aren't balanced like that, if one, like if these two are strong and this one's not really there, that's kind of the way it is with this radio, then that starts indicating an alignment issue. But the sound is pretty good on this.
Fast food category for more than 80 years, and is now owned by legendary investor Warren Buffett, who knows a sweet deal when he sees one. Aston Martin has been driven for over a century in spite of multiple bankruptcies and a parade of owners, proving it can't keep a good brand down. With 500 million Bazooka gum pieces being sold every year by the late 1960s, Bazooka's gag writers found themselves with the title of world's best-selling authors. Unlike Phantom of the Opera, which rarely made dramatic changes from its original version, each of these brands today survive because they did change to keep up with the times. Tussauds Museum always features the most current celebrities, Dairy Queen ventured into hot food, Aston Martin is about to launch its first electric model, and Bazooka Bubblegum looks nothing like the good old days. It's the secret to long life. Keep your core intact, but roll with the punches. I'm Terry O'Reilly.
I really enjoyed this guy's show. We're listening to the CBC, and I think almost every day at this time, this show comes on for half an hour, and it's very. There's a lot of good CBC radio shows, and it's all on the internet too. I'm sure it's all on everything, everywhere. Well, what do we want to say about this now? So we know this is disabled. This is not seeming to have much effect. Why don't we play with this a little bit and just try again?
First invented, pink was the only food coloring the factory had on hand.
That must be the pink
This
gum.
is CBC Radio 1, 89.3 FM in Maynooth.
This is Cross Country Checkup. For the first time ever, a regularly scheduled national open line program.
And so it began. Hi, I'm Ian Hannamansing. 60 years ago, Checkup broke the mold by handing the mic to everyday Canadians. To celebrate, we'll be in Charlottetown, our next stop on Checkup's Cross Canada tour. Our topic, how are you coping without a family doctor? What impact has it had on your health? That's Checkup from Charlottetown, Sunday at 4 Eastern on CBC Radio 1.
I'm Stu Mills. Coming up on Ontario Today, AI videos that seem to show our Prime Minister hawking crypto investments, a spoof phone call that appears to come from your worried banker.
We want to make sure that you don't lose your life savings, so I went along with it.
Are scams getting smarter than we are? That's next.
This is CBC News. From CBC Toronto, here is the news at 12 o'clock. 6 degrees, mostly cloudy in the city. Good afternoon. I'm Cleo Hassanelli. Prime Minister Mark Carney will be in Terrace, BC today, rolling out his government's next list of so-called nation-building projects. One which is expected to get a fast-track today, a nickel mine in Ontario. The list includes BC's North Coast transmission line running from Prince George to Terrace. Our Janice McGregor says that line's expansion is crucial to the projects the government is fast-tracking in the region.
This upgrade to BC's grid.
Okay, but I'm turning that off because I don't think we need to listen to the entire news. But if you're not Canadian, what you might want to know about Canada is, in terms of what's happened with the United States and the like, is we're basically turning away from the United States and trying to engage with everybody else in the world and engage with ourselves, which is more important yet. If we have people in our country who are building stuff for sale outside the country, then those people are not helping the country directly. Their effort is being sold to another country. So we can't do some of that anymore because I guess, because of the American president has said he doesn't need anything from Canada. So, okay, well, we need stuff from Canada. So you're hearing all these projects that are coming out. These projects are intended to keep our industries rolling while we build out our own economic future, building ports and all this kind of stuff. So that's what's happening in Canada. We're not trying to maintain our relationship with the United States. We're not. I mean, if we do in the end, well, that's great. But if not, we're not counting on it. That's for sure. We're really not counting on it in this country. So, okay, enough of that speeching. Very good. I think I did okay today. Really not sure what needs to be done to this at this point. There are some electrolytic capacitors. You should probably get rid of them. Otherwise, this thing is working really well. And sounded great, in fact. Thanks a lot for watching. I'll see you on the next one.